Okay, welcome to today's lesson. It's about area problems and problems without solutions. Let's move right into area problems here. So I'll give you the first example here. Go ahead and write it down. You can pause this video if you need to. But here's the problem. A rectangle is 5 centimeters longer than it is wide. If its length and width are both increased by 3 centimeters, its area is increased by 60 centimeters squared. Find the dimensions of the original rectangle. Okay, so first thing you want to do is draw this out. These are a little more difficult than you're used to. So let's draw a picture here. So I'm going to draw a rectangle, and it says here that it's 5 centimeters longer than it is wide. So the length is W plus 5, and the width is W. You guys are familiar with this. But now there's a second part to this. The width and length are both increased by 3 centimeters. So I'm going to draw that now. Look, I've got this dotted line here. And they're both increased by 3. So you can see that this section is 3 and this section is 3. Okay, so let's remember that area equals width times length. And we're going to make a chart. So go ahead and draw this chart. Again, pause the video if you need to. We're going to start with the old triangle. That's this inner blue section here. And its width is W, and length is W plus 5. So if I multiply those together to get my area, I'm going to get W squared plus 5W. Now I'm going to do the new triangle. So the width of the new triangle is W plus this 3 here, W plus 3. And the length is going to be W plus 5 plus 3, which is just W plus 8. And the area, I multiply width times length there. I'm not going to multiply it out there. I'm just going to write the two binomials. Okay, so now we have to figure out our problem. And it says that the area is increased by 60 centimeters squared. So that says the smaller width, or the smaller area, plus 60 equals the larger area. So the area of the new equals the area of the old plus 60. That's what I just told you. The area of the new, that's a big rectangle, equals the area of the old, the blue, plus 60. They said this is 60. That's what it's telling you. Okay, so let's write that out algebraically. The area of the new, which is W plus 3 times W plus 8, equals the area of the old, which is W squared plus 5W, plus our 60 there. Now if you were to figure this out, you would see that the width equals 6, and if I plug in the width plus 5, my length is going to equal 11. Now on your handout there, I expect that you do the algebra in between these 2 points here. It's very simple. You guys can do it, but I expect to see your work. Okay, we're moving on now to problems without solutions. Now, sometimes you're going to be faced with a problem that does not have a solution, and you're going to, well, why is that? Why is it that sometimes a problem doesn't have a solution? Well, here are some possible reasons. Go ahead and write them down on your handout there. Number one, not enough information is given. So, for example, this one right here, Rachel rides her unicycle to the store in 12 minutes. How far away is the store? Well, we know rate times time equals distance. So we have the rate. No, we have the time of 12 minutes, but we do not have the rate. So there's not enough information. We cannot solve this problem. The second reason is we get unrealistic results. The answer does not make sense in the real world. For example, if our answer says the radius of the circle is -9 centimeters, we know that distance cannot be negative. So that's one example. Another example is, let's say you're doing a quarter nickel dime problem and you find out that there are 4.5 nickels. You can't have 4.5 nickels, so it's an unrealistic result. The third way would be the given facts are contradictory. And that's when you get an answer like this, that at the very end of your equation you have like 3 equals 14. Well, there's that 3 does not equal 14, so the problem has no solution. It could also be something like you're reading a word problem and it says the length equals 8. In the next sentence it says the length equals 14. So those are contradictory facts and you cannot solve the problem. Before moving on, I'm going to give you the phrase of the day. And the phrase of the day is 4 less than 3 times a number. I'd like you to write it on your worksheet algebraically. Again, 4 less than 3 times a number. Now, if one of your friends is trying to cheat off you and they want to know what the phrase of the day is, tell them it's squid. And we will know by looking at their worksheet if they correctly did this. Okay, moving on. Let's look at a sample problem of problems without solutions here. Example number 2. Go ahead and pause this video if you need to. A lawn is 8 meters longer than it is wide. It is surrounded by a flower bed 5 meters wide. Find the dimensions of the lawn if the area of the flower bed is 140 meters squared. So again, we are going to draw this out. And first I'm going to draw my lawn, and it says it is 8 meters longer than it is wide. So I have my width of W and my length is W plus 8. Now it's surrounded by a flower bed. I'm going to draw that now. That is 5 meters wide. Notice each length here is 5. So now find the dimensions of the lawn if the area of the flower bed is 140 meters squared. So again, we're going to draw up a table here. I have the area of, I'm going to figure out the area of the lawn, and I'm going to figure out the total area. And by doing that, if I take the total area and subtract the area of the lawn, all that's left is the area of this flower bed, and that's what I'm trying to do. So the area of the lawn is going to be W times W plus 8, which is W squared plus 8W. And the total area is, look, the width is now W plus 5 plus 5. That's going to be W plus 10 for the width of the total there. Now the width of, or the length of the total rectangle is W plus 8 plus 5 plus another 5. That's going to be W plus 18 there. And I'm just going to write that as a binomial times a binomial. Now we talked about this already. The total area minus the lawn area equals the area of the flower bed. So the total area, this dotted rectangle, minus the blue rectangle, that's the lawn area, equals this flower bed there. So let's write that out algebraically. I have W plus 10 times W plus 18 minus W squared plus 8W equals 140. If you figure this out, you get the width equals -2. Now again, I want you to do the algebra in between these 2 points here. It's easy and you're capable of doing it. This is no solution because the width cannot be negative. That's it for today's lecture. Make sure you have these notes handy as you walk in the door tomorrow.